Okay, for this particular problem, this is a look at the central limit theorem, and this is the kind of issue that you're going to have throughout the rest of the class. And that's the difference between a sample that only has one person or thing in it and a sample that has multiple, because the questions are different, but not that noticeably different until you look very close at them. So take a look at this. You've got an elevator, okay? And its maximum capacity written on the wall says 4,000 pounds or 27 passengers. That means that on average, 148 pounds when the elevator is full, each passenger, the average passenger must weigh about 148 pounds, okay? Divide 4,000 into 27, and that's what you come up with. We're going to assume a worst case scenario, in which case the elevator is filled with 27 adult males. Now, their average weight, according to statistics and historical statistics, is the average weight of a man is 189 pounds with a standard deviation of 39 pounds. So we have two questions. If I ask them what's the probability that one randomly selected adult male has a weight greater than 148, or do I ask the question, find the probability that the sample of 27 has a mean weight greater than? That's an entirely different question than one randomly male has a weight. Different question. So how do I solve this? Well, let's do number one first. That's pretty much a straightforward one. So I go to my spreadsheet and I look at the normal distribution. I enter 148 because that's what I'm testing. The mean of men is 189 with a standard deviation, and I want the probability, according to the problem, of being greater than, okay? And so therefore I look at this and I say, which greater than 85%, okay? Now, here's the thing. So now I want the probability that 27 average. I can't do the same thing because now when I talk about the average weight of 27 people, that's not the same as a single person weighing more than 108. It's the average. Some people will weigh less, some will pay more. I want the average to come out to more than, if it comes out to more than 148, what should I do with the elevator? Okay, well, the central limit theorem says that what you need to do is to change the standard deviation and not use 39, but use what's called the standard error, which is 39 divided by the square root of n. And in this case, there are, we said, 27 people in this elevator. And so by the square root of 27. So instead of a 39 here, I am going to use 7.506. When you do that calculation, 39 divided by the square root of 27. Now I get almost 100% probability that this elevator is going to be overweight. Okay, because I'm not going to meet the average. It's going to end up coming out, the average for 27 people is going to be a heck of a lot more than it is for the other. So take a look at that. Please notice. So the individual weights of adult males are distributed this way with a sigma of 39. The average adult of 27 adult males, the standard deviation changes. And it changes by what? It changes by the original standard deviation divided by the square root of the size of the sample. So keep that in mind as you're doing these problems, because it's going to be the thing that's going to trip most people up as they're working these problems. Thank you.